one of the first things that I'm going to need to do is to be able to join this plywood together, which right now is 8 feet long. I'm going to need pieces much longer than that. So I need to be able to join the plywood together. So here, let's take a look at some of the options. Let's say we had a couple boards, just normal boards, and we wanted to join these together. If we were to put the two ends together like this and glue these together, this is what's called a butt joint, and it uses the gluing surface as the end grain, which is a lot weaker than gluing along with the grain or a face-to-face glue joint. So gluing along the end grain is very weak, and if we were to do this without any extra reinforcement, if we go to bend this anyway, over long distance, or even twist it, it's likely that this glue joint's going to fail and it's going to break. So if this is boards, one thing that I've seen people do to increase the strength of a butt joint in boards like this is to, instead of cutting the boards at 90 degrees, maybe they would cut the boards at a 45-degree angle there and cut this one at a 45-degree angle here. And now when you join it together, you still have a butt joint, but you've increased the length of that end grain from this length to something that is now longer. So it's a little bit stronger, but you're still gluing mostly end grain. So it's not ideal. A better way to do this is what's called a scarf joint when we're gluing these together like this. A better way to do this, instead of cutting at an angle this way, would be to cut at an angle along here like this, and then you would do the same thing here. You would cut like that. You would also cut along there. So now when you glue these two together, you're getting closer and closer to along with the grain of face joint. You're still getting some end grain, but by tilting it this way, you're turning it more away from that end grain and more into along with the grain. So you end up with a much stronger joint this way. So, and then, what angle do you make this? I've seen a lot of recommendations that say that this should be about a 10-to-1. So if you've got let's say this is 1 inch thick here, then you would make this 10 inches this way. So you end up with this long, narrow taper, which gives you very good joints if you're dealing with solid wood. Now, we're not working with solid wood. We need to join together plywood. And I have some pieces here. I know this is not plywood, this is OSD. It's composed of not solid, thin pieces of wood that's been glued together with alternating grains, but it's composed of these wood chips that have been going in many different directions, that have been pressed together and glued together. So you've got the grain going in all different directions. So ignore for a moment that this is OSD. Pretend these are just a couple pieces of regular plywood. We still have the problem of how do we join this together. So even if this is regular plywood, we could do a butt joint like this. And again, it's a very weak joint. So one thing that I've seen is, let's say you want to join these two pieces like this. One thing I've seen is there would be another piece coming over the top of it like this to reinforce that joint. This is much better because you end up with face joints here along with the grain. So these joints between this board and this board is very strong, and between this board and this board is very strong. But then you end up with, along the whole length of the joint, you end up with this extra board here, and the thickness changes. You've got this bump that goes along the whole joint. So I want to try to avoid that. So how are we going to join the plywood together without having another board, along the length of this? And by the way, you could do that with solid wood also. If you wanted to join these two boards together, you could come along with another board right on the top and glue that together. You get a very good strong joint there, but it ends up being very thick and difficult to work with. So if we were to take the same principle with plywood that we did with the solid wood and go for a long thin taper to it along this way, well, I don't think that's going to work as well with plywood as it will with solid wood, because again, the grain's going in different direction, and trying to get that to come to a narrow point, a nice taper with those grains going in different directions, I don't think that's going to work out very well. So we need to do something different to join the plywood together. Let's go back to the solid wood. Let me show you another solution here. One thing we could do is like a half lap joint, where instead of cutting at an angle, we cut a notch out like this and join that together with a notch that's cut out like that. So you end up joining these together kind of overlapped. So it's almost like the taper, but instead of taper, you've got, you know, half of your board coming along here. We could even make it a little bit more complicated if we want, make it a step. So instead of a taper, it would be like a step. That's a lot more complicated to do, but it could be done. Now we could do something like that in plywood, which would work out really well because of the layers. Instead of a long, narrow taper, if we were to do an overlap, like cut half of that and straight along here like this, and then join these here, instead of using the big board, let me use the two small boards. If we were to overlap these so that we take out, for instance, half of the wood along the bottom of this, so this is all taken out down here, and then we take out half of the wood along the top of this one, so that this is all taken out up here, then these two could overlap, give a fairly strong joint, and avoid the need for an extra board coming along there. Because we're dealing with plywood, we could take this a step further, and instead of just doing half joints, we could turn those overlaps into puzzles, like puzzle pieces. So we could have something that it comes out and makes well, it's hard to see on there, but let's say this is the plywood. If we were to have something that came out like this, something along those lines, so that the pieces would fit together and lock together with the way a puzzle piece would lock together, I think will be even stronger yet, and that will help avoid the wood from shifting while it's drying. So when we glue the plywood together, you would overlap, press the pieces in, they would lock together like puzzle pieces, and because of that interlocking, we don't need to worry about clamping and holding it. They're not going to shift this way, and they're not even going to pull apart because they're locked in place with those puzzle pieces. It's a little bit more complicated, but that's what I'm going to attempt to do, and we need to make a jig for this. So I'm going to see what I can put together to allow a router to cut out these type of puzzle pieces halfway down the thickness of the plywood, so that they'll be able to overlap and also lock into place. In order to cut the jigsaw pattern, we're going to need to follow a template. And the way to do that is, okay, so the template's going to sit on top of the wood. We're going to be cutting the wood. The template's going to sit on top. So in order to follow that template, we have to install these guide bushings. And I have a set of guide bushings for the router, different sizes. I've already installed the one that is 3/8 inch outside diameter. And by outside diameter, what that means is that's the distance on the outside of these rings that stick up, this bushing here. From the outside of this edge to the outside of this edge, it's a certain distance. So the one I chose was 3/8 outside diameter, and I've put that on the router right here, and it sits around the bit. So I have a 1/4 inch spiral upcut downcut bit installed on this, which means that the direction of the cutting surface is actually changed, so that up here they're going to cut and they're going to push the wood down, and down here when it cuts it's going to push the wood up, so that when you're cutting all the way through a piece of plywood, you're not going to get tear out on either side. So it's a nice bit to have. It's 1/4 inch and it fits inside this guide bushing. And I just discovered, as I was doing this, a problem with my router that has been bothering me for some time, and I just now figured out what the problem is. So the base that sits on the router, this plastic base, is locked in place with these 3 screws. There's no room for adjustment. So I had always been under the impression that this should be centered. However, when I put this guide bushing in and put the bit in place, I can see very clearly that the bit is more to the left side. There's a gap here on the right side of the bit, and it's very close to the edge on the left side, so it's clearly not centered. The way you would normally center that is with a centering tool like this. You would take the bit out, put this in its place, and the tapered edge would fit down in here and center. And once you get it centered, then you would tighten the screws to lock the base in that position. But this base has no room for adjustment. So what I'm going to need to do is I'm going to have to modify this base, open up these holes a little bit so that it has room to be adjusted. And then I can center it, get it exactly in place, tighten the screws, and it should then be centered. Alright, so now I need to remember which holes this went in. This can sometimes be a bit of a puzzle itself. There we go. So they line up now. I took the spiral bit out, and I took the bushing out also. Let me put the bushing back in. All in all, I think it's much better. So this platform looks like it's on steady. I don't think it's shifting. We'll have to see how this works. So I need my collar screw back on. I forgot to put that. Okay, I'll put this on off camera. I'll have to take the bit back out and screw this on. This will lock the guide bushing in place. Alright, so next up is to make the pattern for the jigsaw pieces, and that will have to take into account this guide bushing is, I think it's about a 1/16 of an inch on either side of the actual cutting blade. So that means that the part cut out will have a gap between the edge of the cut and the edge of the pattern by about a 1/16 of an inch. So we'll have to take that into account when making the pattern. Here's what I came up with so far, using a cardboard template that I bent in half to get the same pattern on both sides. And the way I'm thinking this will be is there will be about a a total of an 8-inch overlap between the two pieces of plywood that are joining together, with 4 inches on this side and 4 inches on this side. So I have this piece of OSB that's 2 foot by 4 foot, and I'm going to trace these back and forth like this. Just keep going like that, and I'm tracing them with a thick dry erase marker for 2 reasons. One, it's actually hard to see the pencil lines on this OSB, so this stands out a lot clearer, and I need to make sure that these pieces are going to be cut really twice. So this side will have to be cut on this side of the line, and over here this piece will have to be cut on this side of the line. So I want a 1/8 inch distance between them. So I want a 1/8 inch gap all the way around when these two pieces join, so that the bushing will be able to account for 1/16 of an inch on each side. And when these get cut out, hopefully, if I'm calculating this right, they should join up just nice. So let me finish tracing all these back and forth and cut this out and see if this actually works. The template is cut out. Instead of making cuts with like a scroll saw or something like that, I decided, because I needed to get a 1/8 inch gap, I decided to cut it out with this small trim router and a 1/8 inch single flute bit on there, and I think it worked out really well. There's some, it's a little hard to control the exact cut, so some of my edges might be a little wobbly here and there, just trying to follow the wood. Because the grain is going all different directions, then it was difficult to stay on the path in some places. But I think maybe I could just smooth those out with a little bit of sandpaper, and just result in a little bit extra gaps once it's all put together, but that'll be filled in with epoxy. So I think it's good. This is the type of joint that I think will be really good for epoxy. I've got another video that I'm producing talking about the glass transition point of epoxy. Sometimes it's called I forget, something about a distortion under load test. And what this means is at a certain temperature, usually at around 130 degrees Fahrenheit, the epoxy starts to soften a bit. And this doesn't mean it's failed, but it does soften. And if a joint is under tension at the time that it softens, it is possible that joint could slip a little bit, and then once the temperature cools down, the epoxy can firm up again, but the joint's already slipped a bit. So having a mechanical bond or some form of a fastening device to back that epoxy joint up is always a good idea, and that's what this puzzle piece joint will give us. So when we join the two pieces of plywood together, they're going to be locked in place with minimal movement allowed because of these puzzle pieces, and that's the type of thing I'm going for. It'll make it easier to clamp in place and control the position while the glue is curing, while the epoxy is curing, and it should also help keep it in place in case the temperature ever gets to the point where the epoxy starts to soften. I think what's going to be the most important part of this alignment is going to be this center line here. So what I did after cutting these pieces out is I made sure that with a straight edge that the center line lined up on all of these. So I had to do some sanding. Some of them were a bit higher than others, but I pretty much got the center line lined up on this piece and the other piece. And now if we put these together, let me scoot this up a bit. If we put these together and use a 1/8 inch drill bit to get the spacing, let's say here and down here, then the problem we have is some of these points, like this is what I want right here. This nice 1/8 inch alignment here, right in here is good. This is a little wide, but it's okay. This is a good 1/8. So I wanted to make sure that all these center lines, the parts here, this is a little bit wide, but it's okay. So all of these are 1/8 of an inch. And after aligning all of those, we get some spots here that are binding. They're no longer 1/8 of an inch. I probably should have originally used a larger bit to make this original path, but it's okay. I think after cutting it and aligning the center lines, all I need to do now is clamp these pieces back down and run over this again with another pass with the 1/8 inch cut to make sure that all these gaps are still at 1/8 of an inch. So that's what I'm going to do next. After clamping down both sides on both corners, I turned the jigsaw pieces sideways on the table so that I could clamp them. I ran the trim router back over the line, and we now have a nice gap all the way around, and the centers are lined up. So this doesn't matter right here. It's sticking up a little bit. When I ran the trim router over it, it pushed it down. But the main thing is that the gap is consistent all the way around. Now that the two halves of the original template are done, I need to use them to make 4 more templates. There'll be 2 templates made from each half. And here's the first one that I've roughly cut out. And what we need to do is we need to make a template based on the original template. We need to make a template with just the puzzle pieces that are sticking out with a straight line coming across. So just getting the 4 puzzle pieces sticking out, and then I'll need to make another template with just the puzzle pieces that are coming in on this side, and then do the same thing, 2 more templates from the other side of the original template. So we'll end up with 4 templates out of the 2. And those 4 templates, I'm making that out of regular plywood. Right now I just cut these rough. I'll need to go back and flush cut that and make it exact. The 4 actual templates are now cut out roughly. I still need to flush these up with the original USB templates. Now these need to be brought up exactly flush, so there's no 1/16 inch that we need to leave with the bushing. I'll use a flush trim router bit to get these exactly the same size as the original OSB templates. The original templates will not actually be used to join the plywood. They were just created to get the overall interlocking dimensions set, and then each one of them was used to create 2 additional templates. So here's how this is going to work. Let's say we want to join this piece of plywood right here. The first step would be to take one of these templates with the puzzle pieces sticking out, line it up exactly where we want it, and then cut out completely through the plywood, cut this out completely, and that will result in something that looks like this. So just pretend for a moment that this is the original piece of plywood that we want to join. After it's been cut out with this template, we're going to have 4 puzzle pieces sticking out the end. And then the next step is to take this template and put it up here like this, line it up with this edge right here, and then adjust the router blade to half the thickness of the plywood that we want to join. And what this second template will let us do is cut out half the thickness in each of these inlay areas, as well as cut out half the thickness on each of these puzzle pieces. And that will get it all ready to join up with the other piece of plywood. This will be like half lap joints. So it's not a true scarf joint where it comes to a pointy angle. These are half laps, but they're puzzle pieces. And this should work. I might need some minor adjustment, but overall I think this will work.